In this lesson, we will review an example single line diagram for the Enphase IQ9 commercial system. After this training, you should be able to understand a typical IQ9 single line diagram and identify what Enphase components are required. Let's review an example single line diagram for a 128 kilowatt system using the IQ9N 480 volt microinverters. This example is using 300 IQ9N 480 volt microinverters and is connected by a back-fed breaker. We will start by taking a closer look at the branch circuits on the left side of the diagram. To identify how many circuits we need, just take the total number of modules or microinverters on the project and divide by 30, since 30 is the maximum number of micros each circuit can have. In this example, we have 300 modules, which leaves us with 10 branch circuits, 30 microinverters in each. If your circuits do not work out this evenly, try to do as many as you can with 30 microinverters in each circuit, then have the remaining circuits split into multiples of 3, which will help keep phases balanced. Each full circuit of IQ9N 277 480s have 30 microinverters on it. This means that 10 microinverters are on each phase. To find the line current, multiply 1.54 amps, which is the output current, by 10 microinverters, giving a total of 15.5 amps, then multiply by 125%, giving you 19.25 amps, and an overcurrent protection device of a 20 amp three-phase breaker. When performing calculations for any circuit, it is important to avoid multiplying by the total number of microinverters on that circuit, as these microinverters are distributed across the three phases. Next, you can see that each circuit calls for center feeding. Center feeding is simply where we will connect our home runs to pull power from each circuit. Center feeding is required on every circuit that has more than 18 microinverters. There's an important note on the plans that calls out center feeding for all circuits larger than 18 microinverters. Now let's look at what Enphase components we will need for the circuits. First, we have our IQ9N 480 volt microinverter. Next is the QD cable, which comes in 3 different lengths, has connectors pre-installed that easily plug into each microinverter, and has center feeding connectors pre-installed after every 6th micro connector. Now we have our QD terminators that get installed on each end of the QD cable for each circuit. 2 per circuit is required unless you are end feeding your circuit of less than 18 micros. Next are field wireable connectors that come in male and female and will be used for home runs and jumper connections. Lastly, we have raw QD cable. The raw QD cable is a 4-wire 12 AWG cable that gets connected to the male and female field wireable connectors to create our home runs and our jumpers. Then you can take your power from that home run from each circuit back to the AC PV sub panel board / combiner panel. Next on the single line diagram are the circuit home runs and the AC PV sub panel board or combiner panel. First up are the home runs from each circuit. Enphase raw QD cable can be used as home runs to take the power from each branch circuit back to the AC PV sub panel board, or you can transition from the raw QD cable to whatever conduit and wire you require. Next is the AC PV sub panel board or combiner panel. This is a non-Enphase product and should be sized for the specific project. Each circuit will get connected to a 20 amp 3-pole breaker, and the main breaker should be sized accordingly for the project. The IQ Gateway Commercial Pro does not have to be installed in the AC PV sub panel board, but it does need to be installed close to the AC combined output because the production CTs are only 5 feet long and cannot be extended. It must be powered by a 3-pole breaker of up to 20 amps, has Wi-Fi and Ethernet options included, and it includes 3 revenue-grade production CTs that when the CTs are installed on the AC output, the arrow must point toward the load and away from the solar. Lastly, on our single line diagram journey, we will review from the AC PV sub-panel board to the point of interconnection. Line filters are only needed if the site has multiple gateways or there is significant line noise from heavy electrical motors or medical equipment. Conductor and conduit type and size shall be determined by the designer. Size, number, type, and location of disconnects shall also be determined by the designer. Interconnection method, either a backfeed breaker or a tap, is dependent on site conditions and the size of the existing panel board. Consumption CTs are optional, but if your site requires power export limiting or zero export, you will need to install consumption CTs. The consumption CTs that are compatible with the IQ Gateway Commercial Pro are only rated for 600 amps. So if your service entrance is larger than 600 amps, you can use a remote meter that can be paired with the IQ Gateway Commercial Pro. If you are not sure if your design is correct, let us review it for free to make sure everything is ready for permitting. All you need is an Enlighten account, then navigate to Design Services under the Services dropdown. Fill out all the required information and upload a minimum of your single line and site plan. Once your design is complete, you can use our System Builder tool on the Enphase website to create a custom bill of materials for your project. If you would like to learn more about the Enphase Commercial IQ9N 480 volt microinverter, reach out to your Enphase Commercial Sales Representative or your Enphase Field Applications Engineer.